Hello Algebra 2 Block A students. This is your first video lesson. I told you in class we've been doing this in another one of my classes, and so this is an opportunity for you to kind of experience a different way of learning, using an online lesson to be able to take notes, go over what we're doing in class, and see if you're able to keep up even with me not in the classroom today. So make sure if you have any questions, anything that you see today that you feel is important, make sure you're taking notes and keeping track of whatever needs you might have, and make sure you ask me about them tomorrow or later this afternoon. So we're going to look at rationalizing radicals and complex numbers today. Now, the process of rationalizing refers to when you're rationalizing a fraction, it's the process of eliminating radicals from the denominator of the fraction. In other words, it's a way to simplify a fraction. Just like we reduce a fraction such as 4/8, we would rewrite it as 1/2. We reduce all our fractions. The same idea here occurs. We never want to leave a radical or a square root in the bottom of a fraction. The denominator must always be a whole number or decimal. We're never going to leave a radical in the bottom of a fraction. So let's look at an example of this. Our first example is going to be the square root of 8 over the square root of 3, and we're going to rationalize that fraction. We're going to rewrite it so that we no longer have a square root or a radical in the bottom of the fraction. In order to do that, we need to look at what can we do to the square root of 3 to make it into a whole number. And the easiest way to make that into a whole number would be to multiply it by itself, because yesterday we talked about how square roots and squares are opposites of one another. So if we would multiply the square root of 3 times the square root of 3, we would get 3. It would become a whole number. And now, because we have some understanding of fractions and the concept that I can multiply the bottom of a fraction and the top of the fraction by the same number, so I don't change the value because I'm multiplying by 1. And so therefore I'm multiplying the bottom by radical 3 and the top by radical 3. And that gives me on top the square root of 24. And on bottom I'm left with just the number 3, and that's the whole purpose here, is to get that bottom to be a whole number. Then, just like what we did yesterday, we aren't going to leave the square root of 24. That's not a simplified answer, so if you look in the upper right hand corner, you'll see I've done a factor tree on 24, and I have a pair of 2's and a lonely 2 and a lonely 3. So that's going to simplify to 2 times the square root of 6, and we still have that over 3. So that's my final simplified rationalized answer. So let's look at a little bit more difficult example where you see here in example 2 we have 5 times radical 6 over 3 times radical 10. We have a little bit more work to do here because we have the whole numbers in front of the radicals. And it's the same process here. I want to get rid of the radical 10 on bottom. The 3 on bottom is fine. That's a number, so that can be there. I only need to multiply the top and bottom by square root of 10. On top, that leaves me with 5 times the square root of 60. On bottom, the square root of 10 times the square root of 10 is 10, so I have 3 times 10 on bottom. Now I look at the number 60, and I go ahead and do my factor tree, and you can see that in the upper right-hand corner again. I have a pair of 2's and a lonely 3 and a lonely 5, so that makes 2 times the square root of 15. However, the 5 is already up there, so I have 5 times 2 times the square root of 15, and on bottom, my 3 times 10 became 30. Then on top, I multiply my 5 times 2, giving me 10 radical 15 over 30. So that's where we're at here with our rationalized form, except we never leave a fraction 10 over 30. We know that's an unacceptable value. So we look at 10 over 30 and say I can divide that by 10 over 10 and reduce that to 1/3. So we get 1 times the square root of 15 over 3. And that 1 becomes unnecessary because it's just the square root of 15 over 3. So there's the concept of rationalizing a fraction, simplifying by getting rid of the square root on bottom. If you have any questions about this process, make sure you write something down, and you can ask me later or ask a classmate here when you're working on your worksheet. So we're going to move on to talking about the concept of complex numbers or imaginary numbers. That's an interesting title when you think about complex numbers or imaginary numbers, because really the process isn't all that complex of what we're going to work with. And also imaginary numbers is kind of an odd name because, you know, being a math class, there's not a whole lot of imagination usually involved, but this is something where some mathematicians a very, very long time ago, they came up with this concept of an imaginary value, and that imaginary value was created to solve the problem the square root of -1. If you remember in class yesterday, we talked about how you can never get the square root of a negative number, and we said that had no solution. And that is true. It has no solution in the set of real numbers. However, there is another set of numbers that we call the complex or imaginary numbers, where the square root of -1 does exist. And that's where we get to this new value I. That new value I is created to represent the square root of -1. Just like the letter pi, but it's a Greek letter, but it's still a letter pi, has a distinct value that it's defined for, I is a value that is defined as the square root of -1. It's the imaginary number that was created so that we could solve the numbers that have negative square roots. So I, it'll always be affiliated or always be recognized as the square root of -1. So as we look here at example 3, and you're asked to simplify the square root of -49, what we're going to do is we're just going to rewrite that, the square root of 49, as the square root of -1 times the square root of 49. Now the square root of -1, we just said, can be rewritten as I, and the square root of 49 is 7. So therefore we have I times 7. So our final answer, we always write the number in front of the letter, so therefore our final answer here would be 7I. That's what this I value simply represents. It's a very simple idea that I is the square root of -1. That's what it represents. So let's look at a slightly more difficult example here. The square root of 50. The square root of -50. And so if we rewrite that, we could rewrite that as the square root of 50 times the square root of -1. Basically, we're just pulling the negative out of the situation here. And on the right, I've done the factor tree for 50, and that gets us 5 times the square root of 2. And again, the square root of -1 is I. So therefore, I get 5 square root of 2 times I, which is 5I times the square root of 2. So we're talking about a whole new set of numbers, these imaginary numbers, when really all that we're talking about is we've created a way to find the square root of a negative number. That I simply allows us to say, pretend it's positive, and put an I on your answer to show I took the square root of a -1. So now we're going to do some operations with these complex or imaginary numbers. And a really big idea that we're going to be using here when we try to do these operations with our numbers is that I squared is equal to -1. And you can see the work down here for why that is true. If I represents the square root of -1, we said a square is the opposite of a square root. So if you take I squared, you have the square root of -1 squared. Well, the square root and the square are opposites, so they cancel each other out, leaving you with just the answer of -1. So therefore, I squared, whenever we see that in a solution, whenever we see an I squared, we're going to replace it with -1. Because again, remember, I is a defined value. It is the square root of -1. So therefore, I squared must be -1. So let's look at example 5 here. We're going to do some multiplication of binomials today with imaginary numbers. And so you look at our 3 minus 2i times 2 plus 5i. In order to solve that, we're going to do just what we did last unit, where we would do either the FOILing or the distributing, however you wanted to remember that. And if you look, we did the 3 times 2, which is 6, 3 times 5i, which is 15i. We did -2i times 2, which is -4i, and -2i times 5, which is -10i squared. So that's just the FOILing, the multiplying out that we've done before. Now I'm going to go ahead and combine my like terms in the middle. I have a 15i minus 4i, so that's going to make 11i. So I have 6 plus 11i minus 10i squared. That's what we did last chapter. But now that 10i squared is not an acceptable value. We can't leave our answer that way. So we go ahead and replace I squared with -1 because we know what that is. So therefore, we end up with 6 plus 11i minus 10 times -1. And those two negatives, -10 times -1, cancel each other out to make a plus 10. And then I have 6 plus 10 are like terms, so I can put them together, giving 16 plus 11i. You're going to have a few of these on your homework today, and this is just checking that understanding that if I ever come across I squared in a problem, I don't have to leave it as an I, because that I is not a variable. That I is a defined value. So if it's I squared, I can replace it with -1. If we wanted to, we could replace this I with the square root of -1. We could write it as 16 plus 11 times the square root of -1. However, that doesn't gain us anything. So we're going to finish up here with our concept of rationalizing with complex numbers. Now we're just going to put these two ideas together that we just learned. We learned rationalizing, where we never leave a radical on the bottom, and we learned about complex numbers such as I. And similar to how we don't leave a radical on the bottom of a fraction, we also never leave an imaginary number in the bottom of a fraction. So to rationalize out that imaginary number, we're going to go ahead and multiply by what's called the conjugate of the denominator on both top and bottom. And you see their conjugate is in red because that's a new word for most of us. Conjugate refers to two binomials that are identical to one another except for their sign. For example, if our original binomial was 3x plus 1, its conjugate would be 3x minus 1. If you remember when we did multiplying, we talked about these difference of two squares, how if you would multiply 3x plus 1 times 3x minus 1, you're going to end up with 9x squared minus 1 because that middle term is going to cancel out because they're exact opposites of each other. So if we look at example 6 here, our final example of the day, if you were asked to simplify 3i over 2i minus 1, so this is our original problem here. I want to go ahead and just put a little circle around this so you can see this would be your original problem that you would be starting with from your worksheet. And we want to rationalize that. We want to get rid of the I on the bottom. We don't want to have any imaginary numbers in the bottom of the fraction. To do that, we're going to take our original problem and say, if I would multiply that bottom by the conjugate, I could get rid of that I, and you'll see how that's going to work out here. So the bottom was 2i minus 1. So in order to change it, I'm going to multiply the top and bottom by the conjugate of 2i minus 1, which is 2i plus 1. Now, if you look here, I've gone ahead and multiplied that out. 2i times 2i is 4i squared. 2i times 1 is 2i. Negative 1 times 2i is negative 2i. And negative 1 times 1 is negative 1. So now I've done, on the top, I multiplied 3i times 2i, giving me 6i squared, and 3i times 1, which is 3i. I just distributed the 3i. Now I've done some simplifying steps. On top, I replaced I squared with negative 1 because we don't ever leave I squared. That's a defined value. So I have 6 times negative 1 is negative 6. So my top becomes negative 6 plus 3i. On bottom, I have 4 times I squared. So that's 4 times negative 1, which is negative 4. And I look at my middle terms, plus 2i minus 2i. They're going to cancel out and make 0. So therefore, I've gotten rid of my I term, so all that's left on bottom is my negative 4, and I still have the minus 1 there. That's the whole reason for multiplying by the conjugate, is it eliminates the I term on bottom. So we have on bottom, negative 4 minus 1 is negative 5. On top, we have negative 6 plus 3i. So my simplified form is negative 6 plus 3i over 5. Now this is a very difficult concept. I understand you're going to struggle with this part. Give it your best shot. If you have questions, write them down and we'll talk about them tomorrow. Good luck. If you have questions, you're welcome to come see me this afternoon or we'll go over them tomorrow in class. See you tomorrow.